Welcome to 334 Analyzing Wireless Authentication. So this is about using Wireshark to look at wireless network traffic going on and seeing what information that you can capture. And this is very relevant for things like free Wi-Fi. You might get these at coffee shops or libraries or hotels. And some people are just, hey, I'll just connect to that. But sometimes these free Wi-Fi, they are not very secure because it's so easy for you to connect to those. They sometimes just don't have a lot of security features, and you don't know what that person who set it up has done to it or which type of encryption that they're running. I got some note right here. I want to read this data point right here. It said a survey conducted in 2016 of 1,000 people that 60% of American consumers who believe that their information is safe when they use public Wi-Fi. Only 50% believe they bear any personal responsibility. So a lot of people think that their information's safe, and a lot of people say, no, it's not my fault. I'm not responsible for making sure it's safe. It's the websites that they go to, or the computer itself, or that Wi-Fi. So, that's uh, some evil people that want to steal your information, will exploit that attitude that people say, hey, it's not my fault. It'll be fine. So this activity is about showing you what can be done. All right, so let's scroll through this. So if wireless routers are not configured securely with encryption, that's the data can be seen by anybody. So a lot of times it's just the routers aren't configured right. We're gonna use Wireshark. You could access bank account passwords, credit card numbers. Like, you know how we did packets? Like, what if they're just sending information like that's just plain text? It's not like encrypted and anything. Just, oh, here's your password. That's and depends on how websites and how routers are set up, that can happen. So let's play this video. Oh, full screen. Oh, can you see it all? It doesn't work.
Today, wireless communication is everywhere. In schools, homes, coffee shops, hotels, libraries, everywhere. And most people use it without giving a thought to how it works. But understanding how wireless works is important to understanding its security. Wireless data transmission occurs over radio waves, like music coming from your car's radio. Radio waves are part of the electromagnetic spectrum, along with microwaves, visible light, and X-rays. What differentiates the waves in the spectrum are their wavelengths and frequencies. Radio waves have large frequencies, the number of crests in a second, and long wavelengths, the distance between crests. This means they're capable of traveling through many substances, for example, your classroom walls. Radio waves travel through walls like visible light travels through windows. Of course, unlike visible light, we can't see radio waves and wireless data transmissions. But if we could, the waves would come out of a wireless access point as pulses of energy, spreading in a three-dimensional dome and traveling a distance of 150 to 300 feet. What's in the wireless data? Binary. You may recall that all digital information everywhere is represented as a series of ones and zeros. Binary ones and zeros fly out of a router at a very fast rate. Average home routers can transmit up to 600 megabits per second, or 600 million ones and zeros per second. Devices that get data from a wireless access point, such as a router, interpret the ones and zeros and use the data as intended. For example, to display a speech on your smartphone. Any device can listen in on the data that is transmitted from a wireless access point. And since radio waves can travel through walls and windows, users don't have to be in the same room or even in the same building to listen to this data. Some materials, like concrete and reflective metal, interfere with wireless signals. But for the most part, wireless frequencies can travel to most places. Wireless data, therefore, is very convenient, but its convenience makes it vulnerable. Malicious users can listen in to wireless transmissions, gaining access to sensitive information. This can happen on the street, outside your home, in an adjoining hotel room, or at the table next to you in a coffee shop. As with most things digital, you can improve a router's security. Instead of transmitting plain text data, you can configure your wireless to transmit encrypted data, data that has been converted to a secret code. Devices known to the router will have a secret key to decrypt or convert the data back to plain text. Your device will understand the encrypted data, but a stranger's device without the key won't be able to. Another security improvement is password protection. Anyone who wants to use the router must know its password to connect to it. The last security improvement has to do with a router's name. Every wireless access point has a name called its Service Set Identifier, or SSID. By default, routers broadcast their SSID to the world so devices can find it. But as you might guess, this lets malicious users find it too. Configure your router so that it doesn't broadcast its SSID. Rather, others must manually type the SSID to locate and connect to it. With just a few simple protection measures, you can enjoy the convenience of wireless technology and know that it's secure.
All right, sweet. So there you go. A little bit about wireless. Talked, I think, some hints about how to encrypt things or how that works. Going through this, Wi-Fi is in the layer 1 and 2 of the OSI model. That's down there in the physical and the data link section. All right. Good news is that this abstraction is exactly the way OSI models should work. Wireshark is limited in what it can do for us. Okay, so this is the bad news. So Wireshark, it can see traffic going on, and you can detect that, but Wireshark is limited. Professionals deal with the problems at the physical layer of wireless using a special piece of hardware called a spectrum analyzer. So if you ever been maybe at an event, I have to do this with robotics sometimes, because you have devices trying to like connect to different Wi-Fi channels, that you can get a spectrum analyzer that just kind of can read all the signals in an area, and you see which signals are out there and how strong they are. You can get an app if you have an Android phone called Spectrum Analyzer that does it. I don't know if you can get one for Apple phones. So we're going to explore wireless issues that are observable in the frame at data link layer 1. And a note here, there might be a bunch of big words, but don't get bogged down by the terms. Focus on security implementations, all right? So if you don't know, look it up too. But there'll be some stuff that we go over. So, all right, I've opened up the lab, and we are going to work on this side now. Okay. Oh, we still had other things on here. Okay, 802.11 packet. The primary distinction between wireless packets and wired packets is the header information. Wireless communication needs additional tracking and management information to handle the more complex job of transmitting data using radio frequencies. What's in the header information? It is protocol information called IEEE 802.11. IEEE, the Institute of Electrical Engineers, is an organization that in part develops global standards in a broad range of industries. Yeah, you'll see a lot of IEEE standards. It's just kind of an organization that controls things or sets the standards. This protocol provides a standard way for all sorts of wireless devices to communicate. For example, the protocol specifies how to break the frequency spectrum into distinct communication channels. So we talked about that spectrum analyzer. If you ever look at that, there's your wireless devices could be on all sorts of channels in there, and you sometimes you want to avoid putting so many things on one channel because they can overlap, they can kind of interfere with each other. But if you spread out your network traffic, less likely to interfere. With channels, many people can share the wireless frequencies and not interfere or overlap with each other. Yep, just what I said. Radio frequencies, just like radio, wireless routers use channels, certain bandwidths. Outside the bandwidth, you don't hear the other radio stations. Outside the wireless bandwidth, you don't see the other users' data. It's like you have radio station channels, you have wireless channels. Unfortunately, channels limit the packet capture ability of Wireshark to one channel at a time. To use Wireshark to sniff wireless traffic, you need to know that channel. So you can't just say, hey, let's sniff all traffic. We can't just sniff all traffic at the same time. We have to check different channels out or know which channel to look for. In this exercise, we use a channel to look at a specific type of wireless packet called a beacon. A beacon message manages the connection between a wireless system, like a laptop, and a wireless access point. WAP. It's a wireless access point, your router. a wireless router. An analyst or attacker can learn a lot of information contained in that kind of message. So I launched the lab. Now we're going to open Wireshark. It's in Activities 334. And we're going to open Beacon. It has one packet in here. Oh, wait, you can't see everything. Why is it all... Oh, wait, I know. You gotta do this, right? Nope. Hold on. It's always weird. Okay. All right, I'm gonna hit refresh. And I'm gonna log in again. Oh, great. Yeah, I love when it does that. Oh, that's my favorite part. Okay, let's do this. Yay. Okay, sweet. We're back. And the packet line. So you got your one capture file is one packet, this one right here. In the packet line, I wish this was like bigger. It seems like it's small. If I hit refresh, you can see it enough. Okay, so I'm not going to mess with it. In the packet line, observe the values for destination, broadcast protocol, and info. Destination is a broadcast. We learned last time it's like you just send that out, not like a specific destination. Protocol is 802.11, and info, so there's a bunch of information in there. What do you expect the broadcast MAC address to be? What is the purpose of the broadcast? If you remember from last time, there was like some default MAC address. Was it all ones or something like that? Oh, all Fs. That's right. It's all F. So if you're broadcasting a message, you're announcing the whole network that the Netgear access point is up and running. Cool. Okay, so this is the access point saying, hey, we started. Cool. In the packet details pane, expand the IEEE beacon frame element. That's this one. And this element is part of the additional header information for wireless packets. Verify the destination MAC address. So destination address says broadcast right here, FFFF. Expand the IEEE wireless LAN area down here. I want to make some more room. And fix parameters. This element's also part of additional header information for wireless packets. Record the beacon interval. Beacon interval is this thing right here. So be 1.0.102400 seconds. Sure. So a little over a tenth. This is how often the wireless access point emits a beacon announcing its existence. Okay, so every tenth of a second it just says, hey, you can contact me. Expand the tagged parameters element, record the values indicated. So tagged parameters down here, SSID parameter set. That's going to be Tesla, it says. Supported rates. Okay, it'll be all those things. So 1B, 2B, 5.5B, 11B. I don't know what the B's are. Okay, we're all doing that. And then METs in megabits per second. If you want to record that, megabit per second. DS parameter set is current channel is 11. 11. Can you think of a few ways the data you collect might be useful to a network administrator? How about a attacker? So knowing the channel would be useful for an administrator or a hacker, definitely. Like what channel it's broadcasting on right here. SSID is the name of your router. That'd be good for the administrator to like connect people and for hackers, especially if it wasn't broadcasting that name. So there's my answers. What does it say? With the beacon message, you can discover wireless access points on your network to manage them. Okay, knowing the name of the network and its channels is essential to acquiring packets. Okay, and timing information may also help understand performance. For the attackers, you want to learn the name of the wireless access point. Channel might give you access and conveniently understand the hardware capabilities or habits of the access point as indicated by interval rates. could be useful. So here's a video of what, I'll play the video over here. And let's play a video on what a hacker could do. So you got your computer right here, access point, and it's checking a few things. And okay, it has like its security in there. But then hacker comes in and can get some information. So if it knows, so I mean that's basically what we're doing in this Wireshark. We can kind of see what information is going out there, and then what it does is it says, oh, it catches, hey, there's this channel, there's this traffic right here on this channel, and then it reads that information and goes, hey, that means there's an access point right here. So that's the stuff you can do. You can kind of sniff out those secret access points. Maybe they aren't broadcasting. All right. So, to mitigate risk, wireless devices can and should be configured with encryption to secure the data they transmit. WEP, Wired Equivalent Privacy. Is an encryption and authentication protocol. It was the original protocol used to provide encrypted communication between a host and access point, and you're going to explore its vulnerabilities. So, whenever you like set up a router, if you've done that before you get a bunch of different options. I think looks like we're going to go through those right here. Cool. WEP, we'll call it WEP, was introduced in 97 and used 40 or 140-bit key encryption. WEP was discovered to have security weaknesses. This led to the development of WPA and later WPA2. So it's like an early encryption, but it was not very secure. So we have better encryption nowadays too. A WEP encrypted wireless device, such as mobile phone, authenticates to a wireless access point using a challenge response scheme. WEP relies on authentication protocol to validate the device's identity. So this is like you go back and forth. So this is the protocol. No, I didn't mean to do that. Oh, go back. Oh, wait, or close. Oh, wait, go forward. Go forward again. Okay. All right, so it's a protocol where it goes back and forth. Authentication requests, challenge, responses, back and forth. They talk a few times back and forth to confirm connections. When a device requests authentication to an access point, the access point challenges it with encrypted text and a shared key, because you got to authenticate that the person is who they are, or someone that is allowed to be on the network. Shared key is a password, or yeah, basically a password, right? If the device can decrypt the text and provide a correct password, the WAP concludes the device is authentic, and authentication is a success. So basically, password protection, right? All right, so next thing. We are going to open up, open up WEP auth. In the packet line list, for packet 1, observe values for source. Okay, in line 1, the source is the netgear. That's like a router name. And info, beacon frame. So beacon frame right here. Okay, so it's this netgear is probably broadcasting that it is an access point. The packet details pane, expand 802.11, wireless points 802.11, wireless LAN. Oh no, it was this one I have. 802 wireless LAN, fixed parameters, and capabilities information. Okay, there's a bunch of stuff. Observe the item labeled privacy and its value. So, privacy. So this is like a bunch of ones and zeros, and like it's kind of like header information, or that tells it like if it says a 1, usually that means it's on, and 0 means it's off. So certain flags, I think that you might hear it called flags, are kind of set. Privacy, it's set to 1. That means it can support WEP encryption. Do you think a Netgear supports any security? Yes, it supports WEP because it says 1. Cool. In packet 2, a wireless client, Apple, so that's a computer, trying to authenticate to the WAP. Packet 3 sees the WAP respond to the wireless Apple client. Let's explore how the WAP responded. Select packet 3. Okay, so it broadcasted, and this is like a computer coming back at it. And so we're doing that back and forth thing that we talked about before. Select packet 3. expand the, let's see. Okay, we're not doing that. Okay, 3, expand this, tagged parameters, and tag challenge. Okay, what are the names and values of the subfields? Okay, so you got challenge text, the length, and the text. Okay, challenge text and the length, and here's the text. So just what I said right there. Boom, boom, boom. The WAP has given this encrypted challenge text to the client to see whether it can provide a response. The client is expected to decrypt the text with its key and return it to the WAP. If the WAP gets the value it expects, the client is authenticating and communicates securely in the network. Securely is a relative term. Okay. Because we already said WP is not as secure as others. So, sure. Apple device responds to the decrypted data. So it says, hey, decrypt this message. And then Apple responds right here and said, here it is. All right, in the packet, select Flame 4 and confirm that the client is responding to the WAP. So we can, Apple is going to Netgear. Yes, they are. What do you think the packet details data field contains? Data. What do you think this contains? Oh, my guess is this data right here is the decrypted text. Like its authentication response. Oh, I'm getting good at this. Oh man, proud of myself. Text has no meaning. I mean, this isn't going to, it's just not supposed to say anything. It's particular. It's using its key to and the information it got to decrypt that data. Packet 5, observe the source. Packet 5, the source is going to be the router again, so talking back. Okay. And info fields. Where's the info fields? Okay, authentication. Got it. This last authentication packet. So boom, 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 boom. Explore the packet details plane. Was authentication successful? Okay, so packet details. How do I know if it was successful? Code success. Oh, it says successful in status right here. So I'm going to say yes, it was, because in these details it says successful. And IEEE fixed parameter status code report successful. Sure. Okay. Cool. All right. Observe the info field. The remainder of the frames allow the client to associate itself with wireless network and set up for general communication. The remainder of the frames allows the client to associate itself with a wireless network to set up for general communication. Okay. Okay, so that's this. Okay, so it's setting things up. Got it. All right, let's get to the next section. For the last exercise, you will use a capture file that contains Wi-Fi traffic from a Cisco wireless router. It includes the authentication session, which means its user provided password connect. You will try to crack the encrypted password. Oh, sweet. Note, capturing wireless authentication data is not trivial and involves discovering a wireless device, finding the right channel, running a monitoring process, forcing the wireless device to re-authenticate, then capturing the data in the packet format, all really close to the actual device. So if you just it's not easy to capture these because, if you're sitting there at Starbucks, you're trying to capture this information, you have to get the time when it's, when someone is trying to connect to their router right away, or you have to somehow force them to reconnect. So it doesn't always happen. Let's go. What's the next thing? Open the wireless PCAP capture file in Wireshark. Okay, so we're going to do the next one. Right here. Okay, so last one of these, Cisco router, broadcasting messages. Oh, there's tons of data on here. So I know we were doing little activities like, oh, here's a few packets. In real life, you're going to have a ton of packets. That's why we got to use filters. Confirm the data captures contains authentication data, including password information you will try to crack. As an ethical hacker, you will perform a pen test to ensure all the devices in the network have appropriate security measures, including strong passwords. Notice the protocol column, 802.11. Many packets are beacon packets announcing the network. So you get a lot of broadcast beacons because, again, like every 10th of a second or so, remember, it was broadcasting, which makes sense if you look at this timeline. You get a new broadcasting message about every 10th or so, a little over a 10th. Scroll down the first packet, you discover an error packet at packet 21. Oh, this one that's black, that's an error packet. And again at 43. Okay, another one. Do I see more? I don't know. Okay, just those two. I don't want to keep scrolling. Select either packet and notice the error in the packet details pane. It says unrecognized flags. Okay. And span the entries and see a frame check sequences error. So frame check sequence error. What does that even mean? Recall that FCS data occurs in the network interface layer. Okay. Normal FCS errors can be caused by other wireless devices that are close to your device. Their radio frequencies can interfere with frequencies. For example, if you and your neighbors share the same Wi-Fi frequency channel, signals would interfere with each other. So, okay, this is a scenario captured in your file. So yeah, so if you got neighbors, your Wi-Fi is being buggy, check your channels. It might be that you and your neighbor are on the same channel, and if you just switch your channel on your router, you might have less problems. So this is a scenario capture file. Soon after error packet 43, the wireless device will re-authenticate. This re-authentication data is what you need. It contains the password you want to crack. Okay, so after 43, it was re-authenticating. Oh, this looks like this one right here. Or maybe some of that information. A new protocol. EAP. Oh, jeez. Okay, they were right about all these new things. YAPL, I'm going to call it that. Extensible Authentication Protocol over LAN. It's used by WAPs to re-authenticate. It is part of 802.11 protocol. Find the first YAPL packet on the packet list. Okay. I'm going to find it. Can I just do a find? YAPL. Oops. Oh, did you hear that sound too? Oh, that's probably pretty loud. Rip your ears. Oh, wait. What's going on with this? Oh, wait. I get it. Hold on. Fixed it. Okay. So, where is it? I don't know. Where is it? I don't. Oh, look. That'd be a certain protocol, right? I guess I can do a filter. Oops. Oh, I can't. Oh, can't type in it. Oh, yeah. It's one of those errors again, right? We get those all the time. Let's refresh. Okay, so there's different types of packets. So let's open this up again. Well, let me type. Okay, down to 87. Got it. So I'm gonna. Oh, I was there. I was. Jeez. Okay, that wasn't that hard to find. I just didn't go down slightly. Not quite enough. There you go. How do these packets details differ from 802 details? I guess look, you got key messages right here. 2 additional entries. Okay, great. What are clues that encrypted authentication is happening in the Apple packets? Okay. So what are my clues? Because it says authentication and it says like WPA and stuff. It includes various key data. You can see enters key. Okay. Yeah. So that's kind of how you know. They have a lot of stuff in there that are related to security. Explore the Apple, and if necessary, other packets. Determine which device is the WAP and to find its MAC address. All right. So let's see if I can figure this out. I assume this is it. Oh, wait. Right? Um, so I guess this thing is it, right? That'd be the MAC address, right? Am I right there? Yeah, you bet I'm right. So boom. So yeah, I go into details and the Cisco, I mean, this is it right there. So let's type, oh, I'm not typing it in. I can just copy and paste. I figured that one out myself. Was the requesting device authenticated? I don't. That's where it goes back and forth, right? The requesting device was this Apple. Acknowledging flags. Um, was it right here? So if we're in 87 still, right? So it's sending the keys, acknowledging, and then authentication. Well, a bunch of acknowledgements. I don't think it was. I think that's the point, right? The error. I don't know. With four Apple attacks packets, each followed by acknowledgement packet, it appears all the authentication information was captured. This is important because we need the password that the client used to authenticate. Okay, so if we go back up to that one, what we're supposed to understand is they had like 4 packets, and so then it probably acknowledged each of those, and yes, it did authenticate. Okay, it did all 4 keys. So it had 4 keys, or 4 messages to authenticate. Okay. Wireshark has another tool to help you find trends in data. Select statistics. Flow graph. Where's flow graph? There we go. Okay. Connection information at a glance. The various sources and destinations display across the top, and the activity between them is shown in the columns. Okay. Oh man, there's a lot of information on here. Okay, and the okay, this is kind of hard to follow. Can I scroll down, or no? It's going to be really funky. Okay, that's okay. That's kind of scary. The various sources and destinations display across the top. Okay, like broadcast, Apple. Okay, okay. So if you want to see it like this, the sources are and possible destinations, and maybe this says, oh, the source to the destination or something like that. Okay. Okay, so like has that arrow to kind of show you that traffic, and there's probably some back and forth traffic too, right? Yeah, like here, so it goes back and forth a bunch. Okay, so even though I'm going back in source and destination, this helps me like see the back and forth of like authentication. There you go. Like here with the keys. This way, back and forth. Okay, I get that. That's cool. Um, Scroll down to the graph to see a burst of activity on the second and third columns. Okay, well that would be where I'm at right now. The graph itself is interactive. We'll hide packets if you click on them. Hold down the N key. When is this burst activity? It's basically at that EAPOL part. Around here, we did the key messages, right? EAPOL. And that's that authentication going back and forth. Much of the data you see in the flow graph is shown in the packet list pane, but the format is easier to see some communication trends. Using either the flow graph or the packet list, you can confirm the authentication information is indeed in the capture. Now that you have authentication packets, you're ready to determine whether the packet on the WAP is crackable. Close the Wireshark application. Okay. Closed it. We use a suite of tools called Aircrack. Oh, sweet. We're going back to cracking things. Used by security professionals to monitor, audit, and test wireless devices. That's what I really want to do. Like, who cares if I can see this? I want to be able to crack someone's password at Starbucks. That's the whole point of this class, right? That's why I signed up. Use this tool to determine whether Wi-Fi password is crackable. So Aircrack NG. Click run. Wait, we just gotta, where is it? So you go Aircrack. Oh, where's Aircrack? Oh, right here. Duh. From the taskbar using its icon. Oh, this is the icon. I should pay attention. And let's run. Okay. Okay, great. Okay, using the thing. Okay, so we got this thing open. From file names, click Choose and select and open the capture file that has Wi-Fi authentication. So you are in the desktop just to show you the activities, 334, and the wireless PCAP file. All right. For encryption type, WPA. You may recall that WPA is stronger than the two encryption algorithm used in wireless networks. Even with the improved encryption, passwords can still be cracked. To crack encrypted passwords, you need to provide a list of words. The program can choose to compare passwords. For word list, choose the dictionary word file. Okay. So I think when we jumped around to unit 4, and maybe this was before in previous units. It's like one way to crack it is just check the password versus common words, like a dictionary attack right here. So that's where we're going. Should I'll be set to attempt to crack the password. All right. Click launch. Let's do it. All right. New window opens up showing the output of the command line version. Cool. Okay. A lot of SSIDs. Air cracking. Air cracking is that's what it's called. Awesome. Requires one more piece of information, the target, to analyze to the number that indicates the desired device. So what was that desired device? Remember, it was this one, right? Number 4 in the capture file. I think that's what we said, right? Yeah, this one. Wait, whoa, 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 whoa. Oh no, this one. That's the MAC address would be the top one. Okay, so that's what it should be. The crack. Okay, so we're gonna index number. Oh, we just type 1. Here we go. Air cracking displays the number of keys tested, this estimated time to crack, and the encrypting keys used in all the passwords. It may take a few minutes to find the key password. Cracking look at each word in the word list, encrypts it with WPA, and then compares it to the WPA encrypted password key from the capture file. If the two encrypted phrases match, it decrypts the phrase and reports it as a match. Okay. Even with strong encryption, passwords can be cracked quickly. Consider computers that can run 24 hours a day, 7 days a week. Okay, quit all windows and close disconnect the lab. Did it key that found it? Yep, it did. It's called induction, like that. So use a dictionary attack, and it found the key by kind of just testing it out a bunch of different times to get the answers. So there you go. Quit all windows and close the disconnect tab. Why is it easy to crack a weak password? It's easy with strong encryption because one way to check for passwords is you just start with the common words, and this dictionary attack. See if we looked at it right now. I wonder if we can look at that dictionary. Let's look at what it has. That word list is probably, so this is a list of like the most common passwords, and all sorts of stuff will be on here. So if you wanted to do this, yeah, probably some weird stuff's going to be on here too. So I don't want to keep looking. But most common passwords on here, you might even be curious. Maybe try your password and see if it's on here. I'm going to try mine. So this is my most common password, Winheim. It's not on there, so I'd be okay. But, maybe your password was homework. Oh, homework's on there. Another password of mine would have been eighth habit. Still not on there. So, my passwords are better. Sorry. Come up with a better password. Protect against wireless password attacks. One of the best ways to protect is password protect with a strong password. Oh, you don't say. Trying to crack a password that contains mixed cases, symbols, and numbers will take long. So, and I think this is a former activity. Like, if you just do a word, like homework, yeah, okay, one word, that's easy to crack. But, sometimes what you can do is you can use like 2 words. That makes it harder to attack. But if they're 2 real words, it's still just, they take all the dictionaries and then do every combination. It just takes more time. But, given enough time, you run a computer 24 hours a day, you can eventually crack things. You're not going to crack in the 2 minutes that we did it, but you can crack it. And so it's what special characters kind of help out. But even then, if you use the same special characters, like you replace all your A's with an at sign, that's obvious. Or put the exclamation point at the end of your password for a special character. I do that, especially when they require that. But those things are obvious. So it is, things to watch out for. All right, that's it. Hope you enjoyed.